Jackpot. Uh-oh. Elijah?
Yeah.
Okay. I got to fix your attendance.
So I got my lunch. So I'm confused.
It's okay. I'll fix it. Just make sure I fix your attendance, because I might forget. Oh. Okay, ladies and gentlemen, let's talk for just a little bit. A couple of housekeeping things we got to do, and then finally I get to do what I get paid to do. So this is your notes for the entire year, okay? Open it up, and the very first page you will see is a formula sheet. There's a formula sheet front and back. You are allowed that formula sheet on every test. You are allowed it on the AP test. I really don't believe you will use it very much at all. However, it's there, and if I allude to it or if you use it, it's there, okay? Just leave it in your, I'll give you one on each test, so you don't have to use this one. However, this one's available to you at all times. There is a table here that we will use quite a bit, not anytime real soon. Here's the other part of the table. Here's another table, and here's another table. None of those we will use anytime real soon. And then this last table, table T5, that one we will use maybe a little bit today. This is just a random digit table. So if you need any numbers for anything whatsoever, that's the table you use. And you basically start anywhere you want to. And if you want to start on the right-hand side and go to the left, you can. Or if you want to start at the bottom right and go up, or however you want to do it, it's just random digits. That's all it is. Okay, so if I'm going to select from your class, from this class, I would number you guys from 1 through 20. I would number you 1 through 20, and then I would start wherever I wanted to. Good gosh, I can't see it though. Sorry. Let's start at 130. So the very first number I would choose is 69. Well, we don't have a 69 because we can only go up to 20. So then I'd go to 05. So whoever number 5 is the next one. So I don't do single digits because I went up to 20. I have to do 2 digits. And so when it was 05, that chose number 5. If it was 3 digits, and if it was up to 100 and something, I would have to use 3 digits. So anyway, we'll talk about that as we go. But anyway, that's what that is, okay? And then I got some calculator functions on there. I don't know if those will help you or not. I just had some students last couple of years say that they wanted calculator functions, so I put some on there. The page 13 will not help you at anything. And finally, page 14 starts chapter 4. Okay, starts chapter 4. Do notice this, guys. Our chapters in the book do not line up with AP units. So AP has 9 units. We have 12 chapters. So for instance, you will see unit 3. And I only do that as if for some reason you're going into AP Classroom. If you go into AP Classroom and you look up Unit 4, you're going to find nothing that I'm talking about because that's Unit 3. So their Unit 3 is our Chapter 4. Their Unit 1 is our Chapter 1. Their Unit 1 is also our Chapter 2. And then their Unit 3 is our their Unit 2 is our Chapters 3. Just kind of, it's a little confusing. I keep up with chapters, but I just don't want you to go to AP Classroom and try to struggle to find it, okay? So that's why it says Unit 3, Chapter 4. You'll see that 4-1's on the first page, 4-1's on the second page, and then it starts 4-2, right? So that's kind of how they're separated. I pretty much do a lesson a day. Sometimes I get done, sometimes I don't get done, sometimes I get done really early and you got enough time to do your work, okay? And then like I said, it looks like here's chapter 1 and that's unit 1, okay? So that's kind of, it's separated by that. And then so that's rest of the book, except for at the very end, At the very end of the book, I added a couple of more reference for your calculator if you need them. Again, that's just what students asked. They said, I really wish we had something to go back with on the calculator. If you're having a tough time with something with the calculator, you're better off finding YouTube than this. I'll be honest with you. YouTube will show you how to do it, all right? And then the last thing I added this year, I added this year. This is like a quick summary of the entire chapter. So you can see it's pretty small, but like this is all chapter 1. This is all chapter 2. Next page is all chapter 3 and all chapter 4. So where we take however many pages to do chapter 4, and it's good notes, this is like a quick summary that if you want to just, man, I just want to summarize it or I want to see it quickly or something, this covers everything we need for chapter 4. Okay? And so that's mostly for the review at the end of the year. However, students said that I gave it to them at the end of the year, and there were several students, or some students said, I wish I had that throughout the year. So I added it to the notes book. Okay with all that. So that's yours the entire year. Try not to lose it because that's kind of your lifeblood. I have a couple of extra, but of course that's that. Achieve. We're still messing with that a little bit, but as of right now, Achieve. So you get to it through Clever. Did I talk about that with you guys at all? No? Okay, so you don't have to go right now at all, but don't go right now. With the start menu or whatever, you got the app that says Achieve. Or it says Clever. Sorry, it says Clever. Y'all been to Clever before, yes? And inside Clever, you will see Achieve. A-C-H-I-E-V-E, Achieve. Red little symbol, okay? That's where your homework is. That's where your book is. You're already enrolled in it. And so when you go to Achieve, it will open up and you will see all this stuff on the side here. It should open up to the very first thing now. I think it looks like this. I can't get a student's view on this page. This week, nothing's due this week. Next week, 4.1. This says 4.10B. You won't see that because you're not 0B. You'll see 4.17. So 4.1 homework 7, that's what you'll see. And you can see that it's due on the 19th. And if you don't like this view, you can change your assignments to calendar and it'll show you a calendar, or you can go back to assignments, or you can go to course. I don't know what all you have and what I don't have, but most students see it like this. All of this is all new. They changed it. This is the third time we've used it, and this is the third time they've changed it. So you will see 4.1 homework 7 due Tuesday, and I think I have you do it 12 o'clock Tuesday. At 12 o'clock on Tuesday, you won't see this anymore. It goes away. It goes away. But you will see a 4.1 homework 7L, meaning late. And again, that's just for me. It's the exact same assignment. It's the exact same assignment, okay? But this one goes away. Some students like to go back and maybe look at the homework. So if you want to go back and look at it, you can. If you want to answer them, you can. It doesn't matter. I'm going to give you the higher grade of the two. And for the first couple, I'm still going to give you probably 5 points for both of them because we're still learning the process. Y'all okay with all that stuff? But most of the time, the second one's only worth 4 points. Most of the time, the second one, the late one's only worth 4 points. The first couple, I'll still do 5 points until we get into the flow of things. So that's what you'll see, 4.17, and then if you ever see the L, that means it's the late one. And if I did something wrong, that's where you guys are going to say, I don't see what I'm supposed to see, or you said this, and just communicate with me. Oh yeah, because normally I set this up before you come to class. Okay, so that's what you're kind of see for your homework. So when you open it up, maybe there. Eventually it gets there. Eventually. I can preview this as a student. So this is how it looks to you guys. Loading, please wait, please wait, please wait. Up to 3 attempts per question, minus 10% partial credit for incorrect responses. Again, you won't notice that. I mean, you can miss every question all 3 times, and I still think you're going to get 4 point something. Get immediate feedback, so when you open it up, Dun-dun-dun-dun-dun. There's your question. Here's your answer. You click on it. You check the answer. It asks for resources. It asks for hint, and sometimes they're not worth piddly squat. Even if you guess and you get it right, most of the time the hint says, good job. Okay, thanks. So that's where you guys need to come to class and say, I got this right, but I still don't have a clue how to do it. Help me out. Y'all okay with all that stuff? And so when you get that one, you check it, you can, oh, maybe that's changed too now. Oh, I've got it right. Whew. Okay. Be careful. I put the first one. These get mixed up between students. So the answers get mixed up. So don't say I put A or I put B or what, they get mixed up. Just kind of be aware of that. Okay? View solution. See, perfect. Thanks. I just freaking guessed. I don't have a clue what I'm doing. Thanks for telling me perfect. That's not a whole lot of help to you. But if you hit hint, that's sometimes not a lot of help to you either. Sometimes it is. That's been my biggest complaint about it. But it is what that is. Okay, so that's homework. You guys are on Google Classroom, right? Good. And then AP Classroom at some point. We don't want Drive, we want Google Classroom. And this is 7th hour. I tend to put the slides up a day early. So here's Thursday. Oh, yeah, syllabus. So there's a syllabus quiz. No need to do that right now. No need to do that in a big hurry. At just some point, and it's not really a quiz. I'm not counting it for any points. I just want you to recognize you've seen it and you know what you're doing, and so that way if you say I didn't know that, then I can say you're lying. You did know that because you signed this. It's just something that I do as just a thing. And then here's the slides that we're going to do today. Okay, so you get all those. And then when I get done with this lesson, because I had a rush first hour because I didn't quite get done. When I get done with this lesson, I'll post a YouTube link also right there, and I'll post it for the other class. I typically don't post a YouTube ahead of time. However, sometimes I do. And what I mean by that is this is B day, right? So B day. So if A day meets first, which it happens a lot, then I tend to post both of them at the same time on B days. So it's there early. If for some crazy chance you wanted to watch it first and then come to class, I can't imagine you want to do that. But any questions about all that stuff? Again, housekeeping stuff. At some point, I get to finally do what I'm paid to do. Everybody okay? Babe. I get to do what I get paid to do. I don't get paid a whole lot, but I get paid to do it. Woohoo! Button. I got my button now. I got my microphone. I got my walkie-talkie. This is what the YouTube looks like, just so you know. Here it is. It shows everything here, and there's a picture of me, and there's 4.1, and it's delayed. That's why you can't see me. You'll see me come right through here. See, I'm coming right through here. There I come. Woo! Okay. And all that goes on too. And I need to turn on this. And I need to make this bigger. We're at 4.1. Okay? Yeah. Collecting data. Sampling and surveys. We talked a little bit about this Tuesday. We talked a little bit about it Tuesday. We'll kind of, like I said, we'll get into it today. You will not need a calculator for this stuff. At 1:30, I think, those that need calculators will go with Miss Chapman down and get your calculators, and we're probably pretty close to being done by then. We're going to kind of play that by ear. So, guys, you can hardly go a day without hearing, learning, seeing something about a statistical study. The National Highway Traffic Transportation, NHTSA, reports that seatbelt use in passenger vehicles increased from 88.5 in 2015 to 90.1 in 2016. At one time, not one time, during that time, it was a big campaign to get you to buckle up. Seatbelts save lives. Buckle up, save your life. That was a big campaign. It was all over commercials. It was all over TV. And so they showed that seatbelts increased. Okay? According to a survey, U.S. teens aged 13 to 18 use entertainment media, whether it be television, internet, social media, listening to music, whatever it might be, nearly 9 hours a day on average. Holy cow. That's a lot. That's a lot. A study suggests that lack of sleep increases the risk of catching a cold. As a study. We don't know a whole lot behind this stuff, but we read it, we see it. Okay, we don't know what's proof behind it. For their final project, 2 AP Stat students showed that listening to music while studying decreased their performance on a memory test or memory task. Again, can we trust everything we read here? Absolutely not. Do we know that there's something maybe behind that? What type of music were they listening to? Was it loud? Was it quiet? Was it soft? Was it headbanging? Who knows what all they're talking about when they're trying to do all that stuff? We didn't see all that information, right? All we saw was that listening music decreases the memory, okay? We're going to look at one of these studies really quickly, the National Highway Transportation one, where the seatbelts went up from 88 to 90, okay? Each year, the National Highway Traffic Safety Institute conducts an observational study of seatbelt use, okay? So they have an observational study for seatbelt use. They send trained observers. I don't know how long this training took. Seatbelt, not seatbelt, 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 not seatbelt. I don't know how much training. You're either wearing one or you're not wearing one. I don't know how much training that took, but they sent a trained one so they wouldn't mess up. They're going to record the behavior of people in vehicles at randomly selected locations across the country. So this is trying to paint me a picture. Okay, now I at least know that they picked some random intersections. We don't know where, but we do know it's across the entire country. It's not just here in Arkansas. It's not just here in Bentonville. It's not in the South. It's the entire country. Okay? The idea of an observational study is simple. You can learn a lot just by watching or asking a few questions. I can learn a lot just by watching you guys as students. I can learn a lot just by asking you guys questions. I can't prove anything, but I can learn a lot, okay? As a survey of teens and media, Common Sense Media conducted this survey. So I guess it's a Common Sense Media. That's who conducted this survey using a random sample of $13.99. Now, why in the heck they just got $13.99, I don't know. Could get one more person, get me $1,400, but they got $13.99. And how the heck they knew, I guess they're trained, that they knew that they were from 13 to 18. But that's what they said. They're from 13 to 18. Both of these studies use information from a sample to draw conclusions about some larger population. In today's section, we're going to look at these issues involved with sampling, and then we're going to look at surveys. Okay? So that's kind of getting you prepared for what we're going to do. Here we go, first definition. And I'll put this out front, guys. I will never, ever, ever on a test ask you for a definition point blank. However, if you don't know what the population is on the test, you're not going to do very well. Okay? So the population is the entire group of individuals. It's the entire group of individuals. Now, and we always assume population to be people. Guys, it doesn't have to be people, okay? I could be talking about the cars. I could be talking about pine trees. I could be talking about whatever it is. It's the entire group. It's all of them. It's all of them. Are we talking about all of them in the United States? Are we talking about all of them here in Arkansas? Are we talking about all of them here in Bentonville? Okay, so the population is just that. I could be talking about Bentonville High School students. That would be all Bentonville High School students. I could be talking about Bentonville High School AP Statistics students. That would be all AP Statistics students. And I could be just talking about 7th hour. And that would be all of you guys. Okay? So that's the population. It's just the entire group. It's the entire group. And then we have the sample, which is a part of that population. It's a part of that population. It's the subset of it, right? I mean, it's about as common sense as you could possibly imagine, right? A sample. It's a sample. It's a part of it. It's a part of it. You guys are a sample of Bentonville High School students. You guys are a sample of Bentonville High School AP Statistics students. You guys are not a sample of Bentonville High School statistics students in 7th hour. You are the population. This table is a sample of Bentonville High School students 7th hour. Pretty easy, yes? Okay. It's very, very important for you guys to distinguish between the sample and the population all year. It's very, very important, and it's not a trick. I mean, they're not going to try to trick you. It's going to be pretty obvious, but you just got to make sure if you're talking about the sample, you make sure you're talking about the sample, and if you're talking about the population, make sure you're talking about the population. And each one of them has symbols for them, so you can't use the wrong symbols at the wrong time. Everybody okay with those two definitions? Pretty easy, no issues. Okay, census. Census. Let's talk about what a census is. Anybody know what a census is? Anybody know? Everybody heard of a census? Hit me. What do you heard about it? That's typically people, right? They do a census I think it's every 10 years. I think it's every 10 years they do a census. They try to figure out how many people are on the, I think it's just United States, but maybe but how many people in the United States at that particular moment in time, which is impossible. Because by the time they get done, some of them have gone and some of them have showed up. But they try to do a census every year, or every 10 years. Every 10 years, they try to do a census. So that's what a census is. It is data from every single individual. Every single individual in that population. It doesn't have to be people. I can do a census of pine trees. I can do a census of tables. I can do a census of cars. But a census is the entire group. I don't think I can do a census of the size of fish at Beaver Lake. I can't even find one in that stupid freaking lake, much less all of them. Fair enough with that? So some things I possibly could do a census, and some things are impossible to do a census. I could do a census of AEP statistics 7th hour average GPA, because all 20 of you cats are here today, and I could get the GPA of each one of you guys and figure out the average of the GPA for this class. I could probably do that. I don't want to say fairly easy, but I could. Y'all okay with that? I'm going to give you this piece of paper. Don't look on the back. You can look on the front all you want to, but I'll explain it in just a second. We're going to do our first little activity here. There we go. Now we're getting somewhere. Ichi ni san. Ichi. Ichi ni. Ichi. 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 Good thing I can't count past 3 in Japanese. Ichi. Is that it, everybody? No, I got y'all? Okay. Here's what we're going to do. We're going to see how reliable a census is. We're going to see how reliable a census is. So, on the back side of this page is a product, i.e. story. It's a product, i.e. story. Well, everybody knows that when products come off the assembly line, some products are bad. Hopefully not very many of them, but some of them are bad. So what our job is to find these bad products and see how many there are. Well, in our story, the bad products are a G. That is a G. There are lower cases G, just to make sure we're not confused. So you're counting all of those on the other side. Easy enough? So everybody knows how to count, and everybody knows what a G looks like. I don't want there to be any bias. You have 2 minutes to do that. Siri, set timer for 2 minutes, go.
2 minutes. Counting down.
14, 15, 17, 6, 5, 4, 1, 3, 8, 21, 26, 21, 4, 15, 18, 13, 17. Huh? Huh. What had lines on here? What do? I did a horrible job. Good enough. Uh-oh. When you get done, put that number on the other side. And you should be done right now. Okay, so we just did a census. We just did a census. It took us 2 minutes to do that census. It took us 2 minutes to do that census. All right? So if I asked you for those numbers, I would have 20 numbers. And 20 numbers, it's hard for me to see anything from it. So what we're going to do, we're going to take a picture of those 20 numbers. And I'm going to put them on this graph up here, hopefully. And then we'll get an idea better. So you're going to tell me your number.
88.
You got 88. That's a big number. I'm going to put a little dot over here close to 88. And you...
64.
Okay, we went over this before of what a G looks like, right? Ooh. Two of the same. Hit me.
76.
Okay, I'm stopping. I know we're all AP students. I know we're all in high school. I'm pretty sure you went over a G. In fact, if you didn't know what a G was, I showed you what a G was, and I'm pretty sure everybody can count.
You're wrong.
What is it?
And we ain't got anybody nobody's got it right. And we did have two people at least get the same thing. So here's what I'm going to try to talk to you guys about, and this is the whole idea of it. How reliable is a census? It's not. It's not. Now, there was some added pressure. I was singing. I was throwing out other numbers. But in the real world, you're going to have some other things affect you, okay? I don't remember, I think there's 15 lines. So let's just say there's 15 sentences or 15 lines. Y'all okay with what I'm saying? Just say that. And I don't really want to count the last one because that's too short. So let's just say there's 15. So I'm going to pick a 15-sided die. I'm going to pick 15 cards. I'm going to throw 15 numbers into a hat, and I'm going to mix it up, and I'm going to pull one number out. You can't go 1 through 15 and use your finger like this. I'm trying to randomly select one of the lines. You can't do this because the middle ones get twice as, this only hits it once. Right? That's not random. So I'm going to randomly select a line. So this is what I'm going to do. I'm going to randomly select one line and count the G's in that one line. Now, if I did that for all 20 of you cats, probably all 20 of you would have a different line. Some of you may have the same line, but you would probably have different lines. Y'all all wouldn't, there's no way y'all all would have the same line. I don't want to say no way. It's really, really, really unlikely. Go back to that word, okay? That y'all all would have the same line. So you're probably not going to have the same number of G's. But whatever number of G's you have, if you multiply it by 15, it's going to probably look something like this. Y'all kind of follow me? So we have the option, counting every single freaking G or one line of G's and multiplying it by 15. Which way is faster? The second one. And if it gives me the same information, why don't we go ahead and just do the second one? Because it's faster, it's more efficient, and it's just as effective. It's just as precise, if there is such a word as that being precise. 88, 54. Whew. Hit me.
How many G's were
Yes.
in the passage?
There is. I don't tell you, because if I tell you, you spend the rest of the class period counting them. So remind me at the end and I'll tell you. So here's my thing about a census, right? A census is not very reliable. I could still get you 20 people in here and figure out what the GPA is of you 20 people, but man, I think I can get a random sample of 6 of you cats and come close, and it'd be a whole lot faster. Y'all follow what I'm saying? That's why we do statistics, guys. We do statistics because I might as well just do it from a small group and predict to everybody, because it's twice as fast, more efficient. I save a whole lot more money, and it gives me the same information. Y'all okay? On your test, it's going to say, on one of your questions, it's going to say, which of the following is least likely to be able to do a census? Well, all of them are not very likely, but which one is least likely? And I think it has something to do with the fish in the lake. Or the amount of the average size of a white-tailed deer in northwest Arkansas. Good luck, right? I don't even know where any of them are, much less all of them. So, the GPA of 7th hour or the GPA of Bentonville High School students? I could do 7th hour compared to the BHS students. Y'all okay with what I'm saying? So census, okay? All right, so let's talk about this now. How to sample bad. How to sample bad. We don't want to ever sample bad, but these are things that help us sample bad. We talked about one the other day, right, when I was asking about if you guys drove to school or not, right? And I wouldn't take a sample from you guys because it would be biased. It would not give me the truth of BHS students, okay? So bias, we got to put a definition with this. Bias. And basically that's what it is, bias. It differs from the truth. It differs from the truth. It's not equal to the truth, what I put up here. The design is how we got the data. Okay, that's what it is, the design. That's how we got the data. That's how we got the data. Well, how we got the data was bad. It was bad, right? Getting you guys for figuring out if we want to drive to school or not is bad, because that answer is going to differ from the truth. It's going to overestimate the truth. It's going to overestimate the truth. If I want to know the average height of a BHS student, I don't think I should take it from this class. You guys are older than the freshmen. However, we're getting close to being done by now, but it's still not a good representation. I can get something better. I can do something better. If you can do something better, then that's what we're trying to do. Okay? Now let me get through this, through your heads. You can never, ever, ever remove bias. You can't remove it. You can't remove it. You can reduce it, but you can't remove it. Okay? If bias is out there, bias is out there. Sometimes it just happens. Our job is to try to reduce it as much as we can. Okay? Y'all okay with the word bias? All right, let's talk about specific biases that are out there that AP wants to talk about. Make sure, this comes up again. We don't need to do it twice. Convenient sample. That always produces bias results. It always produces bias results. Convenience. It's convenient. Right now, I'm going to do a sample. I'm going to use these cats right here because it's freaking convenient. They're right here. They're right here. They're on my right-hand side. I can turn around the board real quickly. It's convenient, right? If you go down to the cafeteria and I do something to a group of kids right there at that table, it's convenient. It always produces, I'm going to say always. How about almost always? Let's use those squiggly words, squishy words. Almost always. There, almost always results in bias. I don't want to say always. We don't like those concrete words in this class, guys. We don't like them. Always. It will. It has to. We like the squishy words. Okay? So convenience. We don't like it. We don't like it. And it's used a lot. It's used a lot. Okay? We don't want to convenient sample. Everybody okay with that word? Convenience? Voluntary response. Voluntary response. You volunteer. People choose to be in the sample. You choose to be in the sample. This pretty much has to be people, right? I can't do trees. You want to be in the sample? I mean, you can't do that with an innate object. Do it with people. Now, be aware of this, guys. They use volunteers a ton in statistics. They use them a lot in statistics. It's okay to use them, just be careful. For instance, I used this one this morning, 0 hour. I want to do a study on the heart rate of 18-year-old female high school students. So I'm going to test their heart rate right now. I'm going to make them run 2 miles, come back, and I want to test their heart rate. Who wants to do that? Well, I ain't doing it. First of all, I don't fit any of that category, much less running 2 miles. Okay with that? But if I get some volunteers to do that, it's okay. I can learn about them, but I can only learn about 18-year-old females. Y'all okay? I can't learn about anybody else. I can't. So they do that a lot, but just understand that bias can occur from volunteering. Most of the time this happens with surveys, right? When you volunteer for something, when you get a review, when you put a review on Walmart or Amazon or something like that, typically you feel strong about it or against it. Very few times, if you're okay with it, you don't write the review, right? You don't write them because, whatever. It is what it is. Or if it's what you expect, when it's bad, that's when you write about the review. That's why I have to be careful about reading those reviews, because most of the time they're negative reviews because it was bad for that person, okay? Internet polls or response, voluntary response. Call in, text in, write in, polls. A lot of that relies on voluntary response, okay? It's hard to distinguish if it over or underestimates, like reviews. I don't know if that overestimates or underestimates. It probably underestimates the truth more than it overestimates, but it's voluntary, right? Some of these get a little confusing because they can fit in both. But voluntary response, you chose to be part of that group, okay? They self-select. They self-select. They're usually not representative of the larger population. If I'm going to ask who wants to run 2 miles so I can test your heart rate, it's probably not representative of the population. You're not getting a 55-year-old man to run 2 miles so they can test my heart rate. I'm not doing it. I don't care what my heart rate is enough for me to run 2 miles. Under coverage. Under coverage. You have all these written already, right? You just got to fill them in. Is that right? Under coverage. You left somebody out. You left a group out. Under coverage. It's underrepresented. Okay, you left somebody out of the group. It used to happen a lot with phone call-ins. Back in the day before cell phones, when everybody had a phone on their wall and they had a phone number that was in the book. So people would look in the phone book and try to randomly call people. Well, the people that weren't listed got left out. And most of the time, that was your upper echelon people because they didn't want their phone numbers in the book. If I did a survey and I just chose people on this third floor, I'm leaving out other subjects. I'm leaving out other subjects. If I just use this class, I'm leaving out other classes. Other grades I'm leaving out. So under coverage, whenever you leave somebody out, that you want to be part of that population. Now, again, if I'm doing just a study on AP Stat students, I can't do under coverage because you guys cover it. Response bias. Response bias. This one's different than voluntary response. Where's my other clipboard? Back here in the back. No, here it is. Okay, here's your second grade, or your first grade. This is your first grade. We haven't done one yet. It's worth 267 points. 267 points. All points are made up. Abdurrahman, right? What's your favorite class? Oh man, you get all 267 points. Good job. Response bias. It may or may not be true. Your response is true, huh? And dang right it is. I mean, I know it's true. But I bet every one of y'all respond to that. How could I make that different? Make you fill it out on a piece of paper. Make sure I'm not in the room. Right? Make sure you cover all your classes. That kind of stuff. Response bias. You're responding non-truthful when the response is not truthful for one reason or another. Officer Lon Carvick comes up here, asks each individual, do you do drugs? Nope. No, sir, not going to do it. Hate them. I hate everybody that does them. I hate everything. Very good. Wow, 0% of BHS students do drugs. It's kind of, unfortunately, that is funny, but we want that to be true, right? Do you trust tall men with a beard? And the person's got a beard. No, get away, right? It typically happens when something like that, okay? Response bias. It's not truthful. It's not truthful for some reason or another. Whatever it might be, it's just not truthful, right? If I start asking you, like, do you like the school cafeteria food? Yes, 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 yes. I love it, love it, love it, love it, love it. Get to about the 18th person. By now, you're going, dang right, I don't want to be the different one. That's a bad example, but that's different than this one, guys. Non-response is you're not answering. You're not answering. Normally happens with a call-in, right? When you're trying to cold call somebody and you just don't even answer. When the individual doesn't answer. We send some surveys home on pieces of paper. A lot of times those don't get answered. That's non-response. When you go out to eat on a restaurant and they fill out a survey for your waiter or waitress, most of the time that's non-response. You don't answer it, right? Nowadays we fill it out on that little kiosk. Do you want to do a survey? Nope, skip. Okay, non-response. Those are just some of the biases that we talk about in AP statistics. Those are not limited to, those are not the only ones, but those are just some, okay? I'm going to show you in a second an actual AP question, but your job is to recognize that if bias has occurred. And if bias has occurred, then your job is to tell me what the bias was. And it could be one of a couple, it doesn't matter. It could be non-response. They left out somebody under coverage. They could be voluntary. I mean, it could be one of 3 or 4 of them. All your job is to tell me it's one of them. Just don't lie. Don't lie. Don't tell me wrong one. And then you better tell me why it's over or underestimated the truth. Don't tell me it's different than the truth. Don't tell me it's just different. You got to tell me it's over or under to get the full points. Okay? So they typically are looking for 3 things on a free response question. That's your job, is to find the 3 things. So what the bias was, how it's different, and if it over or underestimates the truth. Will increasing the sample size reduce bias? And this is where a lot of students think it will, because we talk about increasing. I said reducing. Increasing the sample size. We talk about increasing the sample size all the time. I mean, it's common sense. This is like a common sense from statistics. If I increase my sample size, you get a better picture. You get closer to the population. You get, don't say you get more accurate results, but you get more precise results. You get more precise, right? If I judge that piece of whatever coming off the assembly line, if I just do it for 1 hour, I may have 3 or 4 bad ones in that 1 hour. And I may not have any the next hour. In any of the next hour, I just happen to hit a bad hour. But if you have higher hours, then you get a better picture of how many are bad products. Okay? Increasing the sample size, will that affect bias? No, it won't. It won't. If it's biased because of the method. It's biased because of the method. If I have non-response bias and I increase the sample size, guess what? You have proportionally non-response bias. If I have response bias and I increase my sample size, you're still going to have response bias. It's the method that I use that's wrong. It's the method. Okay with that? So a lot of times students get that in their head. Man, if I just increase my sample size, I'm going to help reduce bias. You can't. It's the method that we messed up on. We got to fix the method, not the size. Not the size. Okay, pencils, happy, happy, go, go. It's almost impossible to remove it. Don't put down on any free response, we need to remove bias. You can't. You can't remove it. The R word we're looking for is reduce. We're trying to reduce it as much as possible. And when you can't reduce it, which sometimes you can't, then you want to evenly spread it out to where the bias is over here, and I can't tell the difference. The bias is not affecting the result. So that's what our job is to try to do. We want to try to reduce it as much as we can, and if we can't reduce it, then we're going to try to evenly spread it out to where I can't tell if bias occurred or not. It's easier to reduce than it is to spread it out, but okay, how are we doing? Everybody okay with all that stuff? All that talk about bias. All that talk about bias. Maybe 1/40 of the AP test. Okay, when you're asked about bias, because you will be asked for bias on the first chapter. The first chapter test will have bias in it, no doubt. Okay? You will describe how they might respond differently than the truth. Right? How they might respond differently. You want to explain how this difference is going to lead to an over or underestimate. So again, we're going back to driving to school. I chose students that were older. Because they were older, they're more likely to drive. This is going to overestimate the truth. I chose AP students. AP students have a higher GPA than regular students. That's going to overestimate the truth. I chose trees that were not close to the water. Those trees are going to be shorter than the trees that are closer to the water. That's going to underestimate the truth. Y'all okay with what I'm saying on that? Okay? They're going to look for 3 things. They're going to look for context. Context, talking about the trees, talking about the grades, talking about the driving. They're going to look for context. They're going to look for what bias was it, response, non-response, whatever it may have been. And then they're going to look for the over or underestimate. Okay? Those are 3 things they're going to look for. Y'all don't have this on your paper. I grabbed this I just randomly searched for bias on free response questions. Okay, this one popped up. So this was an actual AP question. I don't remember what year. It wasn't last year and it wasn't the year before. An environmental science teacher at a high school with a large population wanted to estimate the proportion of students at the high school who regularly recycle plastic bottles. Interesting little topic. Wanted to know how many percent or what percent recycle. Each teacher selected the teacher selected a random sample of students at the school. Luckily, they didn't take a random sample of science students. Luckily, they didn't take a random sample of, I don't know. They took a random sample of all students. So that sounds good. Each selected student went into the teacher's office one at a time and was asked to respond, do you regularly recycle plastic bottles? That doesn't sound very good. That sounds like an iffy situation. It sounds like we got bias going on. That's okay. They didn't ask us anything yet. I don't care, but I kind of got that in my head. Based on the responses, a 95% confidence interval. Now, that means nothing to you until second semester, but we got a 95% confidence interval for the proportion of all students who would respond yes. So they say it's basically between 58% and 82%. That's a pretty daggum big wide range. But 58% to 82% said that they do recycle. First question is, how many students were in the sample were selected? Well, you got no clue how to do that until second semester. Given the method used by the environmental science teacher, they're reminding you who did this. To collect the responses, explain how bias might have been introduced, and describe how the bias might affect the point estimate. The point estimate is the average. Okay, the point estimate is right in between that. Of the proportion of all students. Who said yes? We're okay to answer that now? The students were asked by the science teacher. Because it was a science teacher, they're more likely to respond yes. Because they don't want to tell that science teacher that I'm not recycling. This is going way above and beyond. Because of that, I believe that this is overestimated from the truth. And that would get you by far full marks. As long as you talk about science teacher and the students answering non-truthfully, and you don't even have to say response bias if you don't remember what the bias is. The students are lying, or they're probably lying. If you say it like that, they're okay with that. They don't care. They're probably lying. It's going to overestimate the truth. Good enough for that? Okay, now let's talk about how to sample well. So that we don't have bias, or let me rephrase that, so we can reduce the bias as much as possible. Okay, so this is how we're going to sample. I may have jumped a little bit. Does it go in notes okay? I updated my notes. I cut back on my first year teaching. If you saw my notes, whoo, these notes were like 6 pages. Man, I used to give so much information. It was too much. It was bad. Simple random sample. Simple random sample. This is what we're going to use 95% of the time. Probably 98% of the time, but all this stuff's made up. But we're going to use it a lot. Simple random sample. And yes, guys, you can abbreviate simple random sample as SRS. You can abbreviate as SRS. If you write down SRS, I know what you mean, and the people that grade your test know exactly what you mean when you say SRS. Simple random sample, okay? And what that is, I don't like this definition. I probably need to change it. But basically, everybody has an equal chance of being selected. Every individual, they say group of individuals, has an equal chance of being selected. But everybody has an equal chance. Everybody has an equal chance. So everybody has an equal chance. Every group has an equal chance. This group has an equal chance as this group. This person has an equal chance as all the other people. Okay? So everybody has an equal chance. Everybody has an equal chance. This bothers some of my really talented, I don't say really talented, really mathematical thinking type people. right? If I got 20 students in here and I'm going to do an SRS, if I'm going to do an SRS, the first person has a 1 in 20th chance of getting selected. Okay with that? The second person does not have a 1 in 20th% chance, but they have the same chance as everybody who's left. Okay, so that's what I mean by the same chance. So everybody has the same chance, and once that person's selected, everybody still has the same chance. It's not the same chance as what it was before. I get that, but it's still the same chance. Okay, so don't think of it like truthfully mathematically. Wait, once you select 3 of them, they no longer have the same chance. They have the same chance of whoever's left. Okay with all that? Okay, there's 3 ways you're going to do an SRS. I'm probably going to say 2 ways. I call it one of them the hat method, right? But you got it somehow, no matter what method you use, somehow you have to get numbers with the people, or you have to individualize the people somehow. Number the trees. Number the trees 1 through 40. Number the students 1 through 20. All of you guys have different names. Each student has their own name. Put all their names into a hat on equal pieces of paper. Mix them up thoroughly, pull out 1. Good enough with that? Don't replace it. You actually have to say that. Don't replace it and pull out another one. Do that 5 times until you get 5 people. Okay with that? That's called the hat method. Another one is number the students 1 through 20. Use a random number generator, i.e. calculator, i.e. computer, i.e. some kind of electronic form, to get 5, listen to the word, unique numbers. Because your calculator could give you the same number again. And if it gives you the same number again, you're not going to get 5 out of this 20. You're only going to get 4. And they want 5. We'll talk about it as we keep going, but that's how they're going to ask you to design a sample. This was number 2 on last year's test. Gosh, that took them forever to grade that question because they had to look for certain things, and it wasn't the easy. And not everybody used the hat method, and some people forgot to say "do not replace," and the people who used the computer forgot to say "unique," so all those words ding them. Okay, well, what I'm saying, good. Now, your calculators do have a non-repeat. So you can random integer non-repeat. So you can say that. I'm using a random integer non-repeat until I get 5 numbers. And 4 or 5 years ago, it was like 40,000. Coach, is it okay if I numbered everybody from 1 to 40,000? I think it was like crickets. Can I number the crickets from 1 to 40,000 and put all those numbers into a hat? And I said it was a really big hat. I think so. It's okay, I think. Okay. Somehow or another, you got to label them. Somehow or another, you have to label them. Everybody needs a unique something. Sometimes they're already labeled, like you guys. You already have a student ID that's different from everybody else's. You already have a name that's different from everybody else. So sometimes you don't, sometimes they're already labeled, but somehow you got to label them. And then after you label them, you got to randomize somehow. Use the calculator, use the computer, use the hat, use the table that I showed you guys, the random digit table. Somehow you have to randomize them. Somehow you have to randomize them. And then that's what I'll tell you, right? And then you got to select them. How many do you need? And they'll tell you how many they want, right? They wanted 200 of those crickets out of the 40,000. Your question is going to involve Cheez-Its. You got to randomly select some Cheez-Its. I will use an edible marker to number the Cheez-Its 1 through 40. Any questions? These are the 3 things. These 3s, y'all going to hit these 3s. 3 things are typically what they're looking for in a rubric. So somehow did we label them? Somehow did you randomize them? And again, you got to be careful about that part. Put them all into a hat. If you don't say you mixed them up, that's going to ding them up because that didn't randomize them. If you just put them in a hat, you didn't randomize them any. I double randomize them. I put them in a hat, mix them, and then randomly select. I kind of double randomize them. Don't say this. This is where a lot of students will mess up too. I'm going to randomly number the students 1 through 20. Well, how are you going to do that? You got to explain how you're going to do that. You don't have to randomly assign them. You have to randomly select them. So you can just assign them 1 through 20. Assign them 1 through 20, however you want to do it. Line them up I'm going to line them up from tallest to shortest and number them 1 through 20. Okay, very good. I'm going to start here and number them 1 through 20. Okay. I'm going to number them 1 through 20. They don't care how you number them. You just got to get them numbered. Then you got to tell me how you're going to randomize it. What are you going to do to randomize this? Are you going to use a computer? Or are you going to use a hat? Are you going to use some type of electronic device? Are you going to use a random digit table? One of those three you almost have to use. And then select. And when you select with a hat, make sure you don't put it back in. And you need to say that. And when you select with a computer, make sure you get unique numbers. You probably can get by with that even with a hat. Select 5 until you get 5 unique numbers. So you could replace and get another one, but you got to make sure you get unique numbers or different numbers. Y'all okay? Good? When choosing an SRS, we sample without replacement. Most time we sample without replacement because we already got that information. We don't want that information again. That is, once an individual is selected, they cannot be selected again. Many random number generators sample with replacement. So just be careful of that. Your random digits in your book, you got a chance of being selected again. 16 could show up and 16 could show up again. So you need those unique numbers, or repeated numbers should be ignored. Okay with all that talking about? You'll get some practice on that. All right. Who's got what they need so far? Any questions? Any questions? Pretty self-explanatory. I told you, most of this stuff is really, really like, this is not hard. This is just make you think a little bit, but pretty common sense. Okay. Here's my 3-2-5 secret. We're going to talk about BS a lot in this class. We're going to talk BS a lot. I don't know what you guys think it is. I'm going to tell you to be specific. There's a fine line with being specific and what you think that is. Okay with that? But always in a free response, you got to be specific. Be specific. Talk about, because it was a science teacher. Because it was a science teacher, I've got to make sure I'm probably going to lie because I want to feel good with the science teacher. Okay? You got to be specific. At this point, we're going to focus on AP. Okay? So this has nothing to do with selecting or nothing to do with anything else. This is like the general course. Okay? All of this seems easy. Your job is to hit the rubric. AP statistics rubrics are probably different than any, well, I know they're different than any other math rubric because they don't have points. We're looking for one of 3 things, but we're looking for the rubric, and they will grade it with an E, P, or an I. An A probably gets an E, P, or I, and a B probably gets an E, P, or I, and a C gets an E, P, or I. That question I showed you earlier, A part got an E, P, or I, B part got an E, P, or I. And they give you a rubric on what it takes to get an E, and what it takes to get a P, and what it takes to get an I. Actually, if you don't hit E or P, you get the I. And it doesn't show you how to get an I. E is what? Essentially correct. It doesn't say exact. It's not exact. You can't get exact. You can just get close. Essentially correct, partially correct, and then incomplete. They don't say incorrect, it's incomplete. Okay? Your job is to get as many of these bad boys as you can. Ain't nobody going to get all of them, and you don't have to get all of them. If you can't get all of those, hopefully you can get one of those. But if you don't hit that, then you get this one. Okay? Well, I'm telling you, if you leave context off, it will always drop you from this one to this one or this one to this one. So whichever one you're at, if you leave the context off, it's dropping you down one of them. Makes sense what I'm saying? Good? So always be specific. You don't have to write a novel. You don't have to write a novel. At some point, that starts becoming BS. Just be specific. Say what it is and then get on with it, okay? Talk about it being a science teacher and then class. And because the kid was answering the science, you don't have to write all this down, but you just need to talk about because it was a science and we're recycling, it's probably going to overestimate. But if you don't say because the kid answered the question, it's going to overestimate. You're not in context. You're not in context. Everybody okay with that? The question that I graded this year, I graded number 1. and it had an EP or I for the first one, and an EP or I for the second one, and an EP or I for the third one. And if you got all 3 E's, you got 4 points. And that was the only way to get 4 points. It's worth 4 points. If you got 2 E's and a P, it was worth 3 points. And that was the only way to get 3 points. And 2 points had a bunch of ways. 1 E, 2 P's, 1 E, 1 P, 3 P's. There were a bunch of ways to get 2 points. Yeah, kind of okay. And then if you get all I's in this course, it's 0 points. I think 1 P was also 0 points. Okay, so that's just AP in general. What do I know? What do I know? You don't know what the rubric is. You just got to try to hit it. Or if you can't hit it, hopefully you hit it better than everybody else. Okay. Each year, the State Department of Education randomly selects 3 schools from a district, conducts a detailed audit of their attendance records. Describe how to use, this is a good question. Describe how to use, now they told me what to do. A table of random digits. Okay? Table of random digits to select an SRS of 3 schools. 3 schools out of the 19. So here's the 19 schools. There's the 19 schools. So because I'm using the random digit table, I can't use the hat method. If I was going to use the hat method, I would cut these 19 schools up into equal pieces of paper, put them into a hat, mix up those really, really carefully, randomly select 3. Not putting them back in, or randomly select 3 until I got 3 unique. That would be the hat method, right? The computer, I would number the schools 1 through 19, and I would use a random integer that does not allow repeated numbers and choose 3 of them. But I have to use a table of random digits. So I'm going to number the schools 1 through 19. Somebody might say, I'm going to put the schools in alphabetical order. Actually, they already are. And I'm going to number them 1 through 19. Okay, you just wasted some lead, but you can do that. I want to number the first one 1 and the last one 2, and then bounce back and forth until I get all 19 numbered. You wasted a lot of pencil, but it's okay. You can do that. Don't say I'm going to randomly assign them 1 through 19, because then you got to explain how you're going to randomly assign them. And once you randomly assign them, then you might as well just choose number 1, 2, and 3. So just number them 1 through 19. Use the random digit table. Select row, whatever the row I want to. Select row 27. Start with the first 2 digits. If those digits are not 1 through 19, I'm going to forget about them. And I'm going to go to the next 2 digits. This takes a little while to kind of explain this. And then I'm going to go to the next 2 digits until I get 3 schools for this. No repeats. That would be the hat method we talked about. Cut them up into equal pieces of paper, put them into a hat, mix them up, randomly select 3 without replacing them. Random digit table. So here's the random digit table. The biggest thing is make sure I do 0, 1. I need to number them 0, 1 through 19. If it was 3 digits, I have to number them from 0, 0, 1 through 127. Ignoring everything else from 128. Ignoring any number bigger than 19. Ignore 69. Number 5 is my first guy. And then number 16 is my second guy. And then I'm ignoring 48. And then 17 is my third. I've got lucky. Because sometimes it might take you a while to get 3 of them. Right? If I would have forgot about the 6 and I did 90, 51, 64, 81, 78, 71, 79, I finally got 1. What the heck just happened? That's disappointing. There we go. Questions? Y'all okay with SRS? SRS. You got to know about SRS. Calculators. If you're going to go get a calculator, go with Miss, what's her name? Chapman. If you're going. Okay. Okay, that's fine. That's fine. That's fine. And if not, I mean, there's not very many of you guys if you're just going to, but go ahead. Go ahead. Go ahead. Yeah. Oh, no, I don't know how long it's going to take. Yeah, probably just leave it. Anybody else? Anybody else need to go get a calculator? Go ahead. Hit me. Go ahead. Just you got to have your ID. Y'all got your IDs? You got to have that. Just make sure. Yep. Yep. Okay, so we got to talk about 3 more things and we'll be good for today. Stratified random sampling. Stratified random sampling. Stratified. Now, careful. Stratified random sampling does SRS also, but you can't call it SRS. SRS is only a simple random sample. So stratified random sample. Guys, in stratification, you're putting them in homogeneous groups. You're putting them in homogeneous groups. Some way, some form, some fashion. The trees next to the ocean, or sorry, next to the lake, trees not next to the lake. Boys, girls, juniors, seniors, freshmen, sophomore. I'm putting them into groups. Some way, some form, some fashion. Some way, some form, some fashion. I'm putting them into groups, and then I am randomly selecting from that group. Then so then there's an SRS. All these have an SRS. It's just when does the SRS occur? So you put them in homogeneous groups. Hit me. So, yeah, and we'll hit one. So I'm going to do a random sample from this class, right? And I'm going to randomly select 4 of you. Is it possible that all 4 of them be female? Definitely. Is it likely? We're pretty close to it. Now we're talking probability, right? Well, if I want a random sample and I don't want a representative of all females, I want to make sure I got some guys in there, then I'll stratify them. And I'll get 2 from here and 2 from here. Then I'm guaranteed to get some from both. If I do it with school, I'm guaranteed to get seniors, sophomores, freshmen, juniors. I'm guaranteed to do that if I stratify. If I don't stratify, I'm not guaranteed. Probably will get some. What I don't want probably, I want to make sure I do. I want to what? Reduce bias. I want to reduce bias. And so in order to reduce that bias, I can do that. Okay? Because everybody knows that females have different minds than males. Hit me.
Would it ever be a good idea to do that in a place where the homogeneous groups aren't equal in size?
So that's the issue with it. That's the issue with doing most people this way. How do I want to say this? This typically gives me a more precise estimate. It gives me a more precise estimate because you're getting more, but the problem is it puts equal weight on a lower represented or lower proportion groups. Yeah, it puts an equal weight on a lower proportion group. So if this class just say had 19 females and 1 male, lucky guy, right? And I'm trying to randomly select, and I want, well, I can't even choose 2, so let's go 18 and 2. I got 2 and 2, well, now they're getting 100% of the representation. So I don't, again, depends on what information I'm trying to find. All this depends on what kind of information I'm trying to find also, right? If I'm using you guys as a random sample from Bentonville High School, I'm probably okay. So that's what we talk about here is the advantages and disadvantages. And the advantages is this is typically more representative. It's typically less varied, meaning, listen to me please, don't say more accurate. Accuracy, you either accurate or you're not accurate. It's more precise. So less varied, more precise. Okay, typically it is. Typically it is. Hit me.
Could you do a smaller sample size for smaller groups?
You could. Again, it all just depends on, yeah, it's so many what ifs.
Would that still count as homogeneous if it's like, if it's a smaller group for one than the other?
So we got another one for that, I think is where we're going to on that. Great questions. If they're already divided into homogeneous groups, it's a lot easier. You guys are already divided, freshman, sophomore, junior, senior. So it's pretty easy to randomly select from that. Just go ahead. You're probably all right. Okay? The disadvantages of this are what we asked earlier about the disproportional groups. It's possible that it could take longer. It's possible it will take more money, right? Because now I got to do 2 SRSs. Or in the high school, I got to do 4 SRSs. When if I could just do 1 SRS, it's a little bit easier. A little bit easier just to do 1 SRS, because with 4 groups, now I have to number them 1 through 900. And I got to number the other one 1 through 900, and the other one 1 through 900, and the other one 9 through, and then I got to randomly select from each one of them. It just takes a little bit longer, but it's more precise. It's more precise. It's less varied. It's typically better representative of the entire population. So depending on what we're trying to find out, typically it's worth it to do it. Y'all okay with stratified? So we have SRS and we have stratified. Simple random sample, which is what we will use 95% of the time. Sometimes you'll see stratified. Okay? This is always the question I get asked, is the difference between stratified and cluster. So everybody done with stratified? Everybody okay? I don't want to go too fast. Cluster. Cluster. I don't want to say you want to put them in groups. Typically, they're already in groups, but we don't want them homogeneous. So they're in groups. Randomly choose groups. Randomly choose groups and survey them all. Randomly choose a group and survey them all. This is typically a little bit faster, a little bit less money, a little bit easier. However, it could also be more varied. What information am I trying to find? Okay, so if I was going to cluster this classroom right now, you guys are somewhat in clusters with your tables. So I would randomly select a table. I would number the tables 1 through 10. Randomly select a table and survey all of them at that table. Now this class is smaller than my other one, so I'd be in trouble if I just got the singleton. But that's what cluster is. You try not to have them in homogeneous groups, because if they're in homogeneous groups and you survey them, you're probably going to get the same type deal, and now you're going to get biased results. But again, it depends on what we're trying to look for. What we're trying to look for. Okay? So cluster. Cluster. It's when the randomness occurs, guys. If the randomness occurs at the very beginning, it's an SRS. At the very beginning, it's an SRS. If you put them into groups, if you randomly select a group, it's cluster. If you randomly select from the group, it's stratified. Okay? So try to keep that. It's going to come up in your mind in May, like, oh, I don't remember. I don't remember. Here's my own advantages. It's typically less expensive. Typically, you can get large samples pretty quick, right? I can go down the cafeteria and I can randomly pick a table fairly easily. It's a little bit easier. I can go to a sporting event and randomly choose a section and ask those guys. Again, I wouldn't ask them, how do you like your seats? Because they're all in the same place. But you can get large samples fairly quick. It's disadvantage when those homogeneous groups, or when they are homogeneous groups, okay? Because I'm getting the same information from a larger number, and I probably got some bias from it. So clustering, they don't do cluster hardly at all. They don't do a lot of clustering at all. They do stratified and they do SRS. But they throw this in just enough to try to keep you thinking. This shows up on a multiple choice sometimes. And then one more, and nobody misses it. Unequal size produces bias. Come back to the singletons. Unequal size reduces bias. And then, so this is my stratified. Sum from all the groups. Sum from all the groups. Whereas cluster is all from some of the groups. Okay with that? I'm choosing some groups randomly and I'm getting them all. Whereas stratified, I'm doing all the groups and I'm just getting some from all the groups. So those two do get confusing. Stratified sum, those go together, the S and the S. Stratified sum from all. Cluster is all from some. Okay? That's the best little hint that I got for that. I stole that from somebody. And then the last one is systematic, which also is an SRS, but it's not an SRS. There's only one SRS, and that's a simple random sample. So systematic. You randomly start somewhere. You randomly start somewhere. This is when the randomness occurs. And then you do it's systematic. Every 10th one, every 12th one, every whatever, every 5th one, whatever number you decide to choose, okay? So you randomly pick a starting point. Y'all good? Everything work out okay? Good. Good. Randomly pick a starting point and then go every whatever you decide. Okay? Whatever you decide. Here at Bentonville High School, I would probably go every 15th, maybe every 20th one. Depends on what size I wanted. If I wanted a big sample size, I might go every 5th one. But you can't stop. You can't stop because you're leaving some out, right? You're under coverage. All right, I got mine, I'm done. You got another 400 people coming in. Did you get to school on time? If you miss those other 400 people, you're late. I mean, okay? Okay, y'all good with systematic? This was really simple. They do this at like football games a lot, or I don't say football, athletic events. That's a lot because people are kind of coming in, and every 10th or 12th or 15th one, they'll ask them a question. Hey, where are your seats at? Are you happy with your experience? They do it at voting. They'll do it as you're walking into the store. Now, sometimes they try to grab everybody, but it's systematically, okay? You don't have to number them all. That's what's nice. Hit me.
You said that convenience also produces bias.
Yeah, but this is not convenient. You're randomly starting somewhere, and then you're going every so many one. I mean, again, it depends on what I'm asking, right? If I'm asking, do they like football? That's not a good, I mean, I wouldn't ask that at a football game. Is that kind of, you okay with that? It's because of the randomness. It's because I randomly start somewhere. It's not really convenient. I do understand what you mean by it somewhat. I'm doing that because, like, but I'm having to randomly start somewhere. Possible patterns. You might not get a large enough sample. Again, they don't do systematic very much, and very few times, if they do, they talk about advantages and disadvantages. Multiple choice type question is which type of sampling occurred, and they'll give you some type of scenario, and they'll ask you which type of sampling occurred. Okay, when the randomness occurred is really what you got to focus in on. Randomly pick a starting point and do every 12th one. Nobody misses systematic. Nobody misses systematic. That's like dead giveaway. What do you guys think? Okay. I hope that you can identify the population in the sample pretty easy, I hope, in a statistical study. I hope you can identify voluntary response, convenience sampling, and explain how these can lead to bias. I hope you can describe how to select an SRS with technology or a table of random digits. I hope you can describe how to select a sample using a stratified, using cluster, and using a systematic. And then I hope you can explain how under, non-question wording, and the aspects of a simple survey can all lead to bias. Okay. Yes, ma'am. Oh, I'm glad you said something. Hold on. I got to hit stop. Did you go back and count some?